Algebra 2, Module 4, Lesson 17 exit ticket. It says find the estimated margin of error when estimating the proportion of red chips in a mystery bag of 18 red chips that were drawn from a bag in a random sample of 50. Anybody know the margin of error, the estimated margin of error formula? It is 2 times the square root of, are we talking about a sample? No, we're talking about a proportion here. So the probability, and then this is what I call the, or what's called the complement, or I call it the complement probability over n, which is the number of the random sample. Okay, so what is the probability of getting 18 chips out of 50 chips that are red? That's simply what? How do you do that? 18 divided by 50, right? So 18 divided by 50 is 36 hundredths. Now, the complement would be what? 64. Thank you. Wow. Okay. So 2 times the square root. The probability was 0.36. The complement was 0.64. And all that is divided by n, which is 50. You plug that into your calculator, you'll get the margin of error to be 0.13, we'll call it 6. Okay? That's the margin of error, the estimated margin of error. Now, how do we find, what does that tell us? Okay, explain what that tells us. Okay, what do you mean by 13? Well, let's call it 14%. Let's round it up to 14%. What do you mean by 14%? No, this is the margin of error. The percentage that was drawn out was 36%. Okay? But our margin of error says it could be 14% above it, or it could be 14% below it. So you remember when we've done standard deviation and we would subtract the standard deviation from the mean, and then we also add it to the mean? It's the same thing with margin of error. So what you're going to do here is you're going to say 36 minus 14, and that's going to be 22%. And then you're going to do 36 plus 14, and that's 50%. So the probability of red chips in that bag would be somewhere between 22% and 50%. Okay? That's what that's telling us. Now, how could you decrease the margin of error? How can you decrease the margin of error? Raise the sample size. Now, if you raise the sample size, the variability, standard deviation, margin of error, everything decreases. Why? Why does it decrease? Well, it's more accurate mathematically. Why does it? Let's look at our formula. What's n represent? What does n represent? N. N is what in the formula? number of samples, right? So as that goes up, what's going to happen? As the denominator of a fraction, notice that this is a fraction here, as the numerator increases, as the denominator increases, what happens to the value of the fraction? It decreases, right? 1/10. If we have 1/100th, the value goes down, right? So as the sample size increases, the value is going to get smaller. Your margin of error is going to get smaller. Your standard deviation gets smaller. Your variability gets smaller because your sample sizes are increasing. Okay?